good morning everyone. So in the last class we have started working on the Fourier transformation. So we were actually looking into that if we have any function, we can able to express that function as the series of, in the Fourier series, which are basically containing a0 by 2 plus summation of ai cos I means cos in omega t plus bn into sine b in omega t. So that way the expansion is there, and once we are working on that, and then we try to see that how we can able to idealize any function with that. So we have formulated, means we have using the least square optimization technique, so that we first calculated what is the residue if we assume this term as the approximation of the yt, then how the series can become, and then we try to calculating all the unknown coefficients, namely a1 a2 a3 a4 b1 b2 b3 b4. So all the values we try to calculating. Okay, so we see that if we do, we will get this type of matrix, and if we can able to invert it, we will able to get the solution. But in reality, you see that matrix inverse is also not required in case of the Fourier series. If we are using the Fourier series, this matrix inverse is also not required. We did not did it in the last class. We just completed up to, means we reached up to that point, because that also needs several understanding, because you have to understand where to put in, where to put j, how these two summations are happening, then it makes a complete matrix form. So that we have discussed in the last class. So now we try to see how the coefficients can be calculated without inverting that big matrix. Okay, perfect. So r equal to e0 by 2 minus plus summation of n equal to 1 to capital N a n cos omega n t plus b n sin omega n t. Okay, and we have integrated it as like this way, that one case we are integrating it cos with, like say, cos j omega t into a0 by 2 plus summation of n equal to 1 to n cos yes. So that we were doing, and we say that that is equal to 0. That was what we have done in the last class. Okay, so that was one equation, and another equation is like we were doing it sine j omega t into the same thing a0 by 2 plus summation of n equal to 1 to n cos n omega t plus bn sin n omega t dt, that is equal to 0 to pi by omega. Okay, makes sense? Yes, exactly. Thank you. Yes, you are very correct. Yes, very correct. Thank you very much. Oh, you have to. Perfect. Thank you. Yes, that will be there. R itself is this. You see, R equal to this, and you also just to recall. Look, what was the equation? Because that is if you see here how the integration is happening, you will have 2 comes out, so 2 are cos of this and 2 are sine of this. Okay, and now you can forget the 2, because 2 is 2, it will be just out. And okay, so we will have these two things. Now again, first trick, this equation, suppose if I say 1 and this is 2, if we do equation 1 for omega equal to 0, that is 0 to 2 pi by omega cos of j omega t a0 by 2 plus n equal to 1 to n 0 to 2 pi by omega cos of j omega t into cos of in omega t dt with an plus again integral 2 pi by omega cos of j omega t into sine of in omega t that we can able to write. If I expand that equation, it will comes like that. Now if you see, this part is always 0 because cos of j omega t into sine of in omega t, whatever cos with sine, always it will become 0. Okay, so we get that. Now if you see, so this portion is automatically become 0, and once I am doing that, so this can be written as integral 0 to 2 pi by omega cos of j omega t e0 by 2 plus, and in this case only one equation will be remained, that will be integral 0 to 2 pi by omega cos square j omega t into aj. That will be only remain thing, because all other term will be actually 0. If I just see that expansion, so only one term will be remained exactly. Okay, so that part is gone, and dt here is with gt, and integral 0 to 2 pi by omega cos g omega t yt dt. Now if I just put j equal to 0, in that case what will happen? We will have 0 to 2 pi by omega, because that portion will become 1. Okay, so in the between portion, actually what is happening, if you see, once we are putting j equal to 0, then actually aj is not there. But a0 already is there. That is valid from 1 to n, not for 0. Not for 0. So that is the problematic thing happened. Okay, so we will have this. So now if we see, now if we try to do the integration, so what it will come in? It will be 2 pi by omega into a0 by 2 will be equal to, here also 2 pi by omega, not 2 pi by omega, sorry. This way the scenario happens. So a0 will be equal to, it will be pi by omega into 0 to 2 pi by omega into y of t dt. So that will gives you the value of a0. aj is actually what happened here in this point. If you putting that j equal to 0, so what will be the value of aj? aj is not defined in that portion, because aj then become a0, but that is also, if you see, the summation is starting from 1 to n. That is not for a0. So that's why this full part gets skipped in that point. Okay, but other cases that part will be there. Here this gets skipped, and these are some of the tricky thing what are there. So you will get in this way that a equal to this. Okay, now the next one, how you can go ahead. So next one you can do it like, now you can use this equation. So now you know what is your a0 by 2, and your target is to find aj. So you can go for j equal to 1, j equal to 2, j equal to 3, like this way, and it can be evaluated. Okay, so in that case you will get like a j equal to, you will get 1 by omega by pi. Yeah, omega by pi, exactly, it should be omega by pi, omega by pi. So here you will get omega by 2 pi, 0 to 2 pi by omega, that will be y of t into cos j omega t dt. That will be your aj, will come like that. And what will be your bj? Bj will be omega by 2 pi, again 0 to 2 pi by omega y of t sine of j omega t dt. Okay, that way the things will come. Now one interesting thing you can also try. So what we got y of t equal to a0 by 2 plus a in cos j cos in omega t plus b in sine in omega t in equal to 1 to n. Okay, that we got. Now we see that a0 by 2 has some value. So if I just put it like this way, that cos of in omega t will be equal to e to the power of I in omega t minus I into e to the power of plus minus I in omega t divided by 2, and sine of in omega t will be equal to e to the power of I in omega t minus I in omega t divided by 2. So that is nothing but the Euler's expansion, how we can write it. So if I substitute that here, so my y of t will become a0 by 2 plus summation of n equal to 1 to n in e to the power of I in omega t plus e to the power of minus I in omega t divided by 2 plus bn into e to the power of I in omega t minus e to the power of minus I in omega t divided by 2. So you will have a0 by 2 plus summation of n equal to 1 to n a in plus bn by 2 e to the power of I in omega t plus n minus bn by 2 e to the power of minus I in omega t. I will be there. 10 by 2i, yes. Not here. So what will happen? So you can get like this way. So this one will be not like that. This one will be minus I beta n, and this one will be plus this. Because I was in the bottom, once it will coming at the top, it will have a minus sign. Okay, because 1 by I equal to minus I square, minus I. means I to the power minus 1 equal to minus I. So therefore it will be like that. So I can write it this plus n equal to 1 to n like Cn into e to the power of plus Cn this one. What is that? Cn bar, that is nothing but the complex conjugate. Yes. So this full thing can be also written as very nicely f of t equal to summation of maybe CR e to the power of I R omega t, r equal to minus infinity to infinity. Means if you see, the negative portion can also be taken care now, very simply. Like if you say, instead of having the two term, if you are not writing the two term, if you are just writing a single term and also 0 is here, and now if you club the full thing, so it is varying from minus n to plus n, complete thing. So that can be, means the, so here it should be written as minus n to n, and that is the exact representation of that. And theoretically it is also extending from, so that is the finite version. And if you say infinite version is, this is summation r equal to minus infinity to infinity CR e to the power of IR omega t. That will be my infinite version of that full form. Okay. A naught by 0, A naught by 0 can be multiplied at C to the power e to the power 0, and then it can be taken care, na? Means A0 by 2 can be written as A0 by 2 into e to the power of 0. So that is I into 0 into omega t. Not a problem. So that n now starting from minus n to plus n, capturing all the points. Makes sense? Makes sense? Good. So like this way we can also able to do that. So here the CR can also be calculated. So now our objective is to calculate the CR. So CR will be how much? So CR is actually, if you see, half of AR minus IVR. That will be, so if you calculate it, it will come 1 by 2 pi into 0 to 2 pi into f of t into e to the power of minus I RT dt. Okay. Or if you are putting the omega, then you can actually convert like t to tau by omega type thing, so that you will get that. Or instead of t, so okay, so instead of t, if you are using omega tau, then you can also able to substitute it like this way. In that case, it will become 2 pi f of, also it will need to be converted. Conversion has to be done. So I r into omega tau, and dt will be omega into d tau. Omega will be coming out, so this one will happen. For t it is then that can also be written. So CR can be written like this also. So these are the two forms of writing the Fourier transform. You can use e to the power function, you can use sine cosine function, and both the ways the things will be like that. So once you have some signal in the time domain, now using the Fourier transformation, you can able to convert it into the frequency domain. Okay. And that CR will gives you what are the frequencies you are, means what are the amplitude of those excitations. So it is basically a summation of several harmonics. Now all the harmonics has some sort of scale also. So that scale you will get from here. Okay. Any doubt? Although it is basically the extension of the previous part, and I made one mistake in there. I'm sorry for that. And please read it. This portion is very nicely given in the appendix of Medovich book. So please read that. I can wait to get it. Perfect. Okay.